Right, so last day we have discussed some topics on map and set. So today we'll discuss two topics, stack and queue, and then we'll move to exception part. Right, so last day we have discussed sorted map, sorted set and iterator. Today we'll discuss the stack, queue, then we'll go for this exception handling. Alright, let me open Eclipse as well, and I'm opening one blank sheet. Right, stack, queue, and then exception handling. Okay, first we'll go for the stack one. Okay, what is this stack? So in stack, like we are storing some data in list or in set, right? So let me show you, or let me remove this because I have to write down some picture. Yeah. If we'll store any value in list, for example array list, right, they will store that value in this manner. Okay, first place, like if you have stored some value like 11, then some you stored 45, 56, and again some value, right, they will store that value in this manner one by one. Okay, in this manner they will store all the value in some order, right? So in list we have their order, so order is preserved in list. Then we have set, right? So we have set, we have linked hash set and normal hash set. So hash set order is not preserved, but in linked hash set our order is preserved, right? Now how will store value in stack? So just assume this one is your stack. So you have seen so this one is what this box is. Just assume this box is bread packet, right? In that bread packet we have bread 1, 2, 3, 4, 5, 6. So this box is full of that bread. All right, so if you want to retrieve any bread from this packet, there is only one option here, right? There is only one option for getting that bread. And if you want to add some more bread, if that box is empty and you want to add some more bread in this packet, what you will do? You have only one way to getting those value, or if you want to store some value into that, there is only one way. All right, so this one is your stack. So in that bread packet, if you want to take some bread from that packet, there is only one way. There is only this way, right? There is only one way for getting that bread. And if you want to add some bread, for like if this box is empty, right, 50% space is empty in this box, so you want to add some bread into that, right? It means you want to add some value to this stack. So this is nothing, this is stack. So this way this stack works. All right, so there is only one way for getting that value, and first if you want to store some value, so in the same way you can store that value. All right, so stack, let me add some note to this stack. Stack or can I take to access or add value in stack. There is only one way. All right, so stacks works on LIFO concept. What is this LIFO? This LIFO means last in, first out. So if you'll add, so let me add some value again, right? So if I'll add this one value to this stack, it means this one is the topmost value, right? If you want to delete some value from this stack, what you'll have to do, you have to delete this first one, means last one. So last in, first out. So whatever value will stored in stack last, you have to delete that value. If you want to delete any value in this stack, so you will delete that last one. So that's why so stack works on LIFO concept, last in, first out. Whatever last value you have added, so just let me copy this, wait, let me copy and we'll rotate this 90 degree. Okay, if you see here, we have stored 11, 45, 56, 87, 454, 34, 34 and 56 in this stack. So if you want to add some value, so it will come to this. After 56 it will come here. If you want to delete some value, so automatically they will delete this last one. So that's why last in, first out. So stacks works on last in, first out concept. Okay, now we'll see how to create object for stack and how we'll store value to that stack. Okay, all right, so inside java.util package we have this stack. So stack is one class. So earlier we have seen like set is an interface, map is an interface, but when we'll go for stack, so stack is one class. So like what you have to do, you have to write stack and then we have to mention the data type of the stack, like which type of data do you want to store in this stack. So for example, you want to store this integer type of value, stack equal to new stack. So if you want to use any class, any predefined class or any user defined class, right, what we'll have to do, we have to create object first to access all the methods and variables present in that class. So we will use this stack class, right? So what is the first step? First we'll create object of that class, right? So we have created object of this stack class. Now how to add value to that stack? So we have one method in this stack, push. In set and in list we have add method, but in stack we have this push method. So I have created this stack object with which data, for which data type, for integer data type. So we'll add only integer value to this object. Okay, so I'm adding one more value, 45. All right, so we have added these three value here, 56, 23 and 45. Let me print that value. If you see, we got 56, 23 and 45. So in this stack, how they have stored that value? They have created one stack object. First they have stored 56, then they have stored 23, then they have stored 45. So in this stack, order is preserved, right? The same way, the way, like first we have added 56, then 23, then 45. We got output in that same order. Why we got that output in same order? Because stack storing that data in this order, bottom to top. First 11, then 45, then 56, 87, 454, 34, 34 and 56. So they will store that data in this order. So that's why if we'll get those data, if we'll print that stack object, then they will print that data in in that same order. All right. Sorry, object stack dot push. I'm adding one more value. Sorry, I missed one semicolon here. So in stack, duplicate value is allowed. You can store duplicate value in stack as well. Like in set, it is not applicable. Set, you can't store any duplicate value. All right. If you want to delete, any value from stack, so you have this pop method, stack dot pop. This pop will do what? It will delete the last value, this 45, from that stack object. So we have added total 4 value inside that stack object, right? And if you want to delete, so if you use this pop method, so we have seen earlier. See, if you want to, if you delete any data from stack, they will do what? They will delete from this top. So they will delete the topmost value. So the topmost, what is that value? 45. If we'll print this value again, this stack object, we got 56, 23 and 45. They have deleted this last one, right? So got it? What is this LIFO? How this LIFO works in stack? Whatever last value you have added into that stack, if you delete any value, they will delete the last one. Last in, first out. We have added this 45 in last. So last in and then first out. If you delete, if you use this pop, it means they will go first. Got it? So this is your stack. So inside, if you want to add any value, we have push method. If you want to delete any value, we have pop method. We have different value inside this stack. Like let me sys out stack dot peak. So we have this peak method. This peak method will do what? It will return the like top, like whatever value it is on that is on top, it will return that one. So wait, stack dot peak. So it will return the topmost value. If I'll print this, we got this 45 here. So at last we have added 45. It means in stack our topmost value is this 45. So this peak will return the topmost value. Okay, and we have one more method in stack, that is search. So if you want to search any value, right, they will return the position of that value. So see, first place we have this 56, second place we have this 23, and third place we have this 45, right? Stack dot search, and if we'll pass 23 here, right? If we run this program, we got here 2, so it will return the position of that value. So 23 present in which place? Second place. So we got 23 here. So this is the use of this search method. Got it? And inside this stack we have different methods. So just do stack and dot, just write stack and dot, then you will get all the method here. See, we have this add method, we have this add all method as well, right? We have this clear method as well, like contains all, we have this contains, we have this empty method. So empty method will check whether that stack is empty or not. We have this equals methods, we can use this equals method as well if you want to compare any value from this stack. We have this index of method, right? We have this is empty method. So we have different methods. Just practice the practice one by one, right? So I've just shown you some main method that we'll use in this stack. Okay, how to create a stack object, how to add any value into that, right? So we have seen this push and pop. So if we directly push any value to that stack, they will store that value from last, like whatever last value. So first we have this 56 and 23, so if we'll add this 45, they will add that 45 after this 23, right? Now stack. So if we'll use this add method, we have both push, pop and add method in this stack. So if I'll add it, for example, I have added 57 here, right? If I'll run this program, first we got 57, then 56, then 23, then 45. So you can add method as well, you can add this push method as well. Both will both output is same. They will the same way they will add that value in that LIFO manner, last in first out manner. Got it? So if you want to store different types of value like string value, so just you have to create a string type of object. And if you want to store any boolean value, so just create that object and you can store that value and use that method. Push, pop, add, and we have peek method, search method, add all method. You can use that, right? So this stack works in this way. Now we'll go for queue. Let me add some note to this stack as well. Stack elements are stored and accessed in LIFO manner. Okay, elements are added to the top of the stack, and removed from top of the stack as well. So if you'll add any value, they will add to the top. If you'll remove any value, they will delete that value from that top. Okay. Let me save this one. 32, save. Let me create a new one. So now we'll see. We have seen stack. Now we'll go for queue. So how this queue works? So stack works on LIFO, last in first out, and this queue. Let me drop this. So this QUUE. So this queue works on FIFO, just opposite to stack. Last in first out. This one is first in first out. So whatever value you have stored earlier. So for example, you have added 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So first in, first out. So you have added 1 at first. So if you delete any value from this queue, they will delete this first one, not the last one. In stack, it is just opposite to this one. If you add these value to stack, so they will remove the last one. But in queue, if you are adding these value, they will delete the first one, because it works on first in, first out manner. Okay, so let me add some note to this. So in queue, elements are stored and accessed in FIFO, first in, first out manner. Okay, elements are added from the behind or added from the last and removed from the front. Let me add some diagram for this. Okay, so this is our stack. So if this is our stack object, right? So if we'll add something, they will add that value from this side. If you want to delete something, they will delete that value from this side, right? DEL, delete. Okay, so this is for addition, this side is for addition, and this side is for deletion. So if you have added some value to your queue, like 10, 67, 60, 68, 70, 43, and some value 21, right? So if you want to add any value, so they will add from this side, from last side. But if you want to delete any value from this queue, they will delete that value from front. Means the first value you have added, they will delete that one. Got it? So this way this stack works. So stack is what? Sorry, queue. So this queue is an interface. Earlier stack is one class, but queue but queue is an interface. Their implementation class is which one? Linked list, right? We have linked list and we have array dq, array dquuv, and priority queue, priority queue. So we have these three class. So the queue implementation available in English class, array dq class, and priority queue class. Okay. So for one by one we'll see each of them. Okay. Let me change the color. These are classes. Implementation classes. Okay. So how to create this queue object? So queue. So again, this queue came under which package? java.util package. So we'll use this one. So I have created queue object for which data type? For integer data type. Queue equal to new. So first we'll use this class. So we have total 3 implementation class: linked list, array dq, and priority dq. So we'll see this one, linked list. Okay, so we have created this queue for which class? Linked list class. Okay, and how to add any value to this object? Queue dot, we have this add method, 10 queue dot add 20 sys out queue. So we got this 10 and 20 here. Okay, we have one more method. If you want to add any value, we have that add method as well. We have this offer method as well. Okay, so you can use both method, add method and this offer method as well, 10, 20 and 89. If you so as we have discussed, if we'll add any value, they will add in that order, 10, 20 and then 89. But if you want to delete any value from this queue, they will delete the first one, the first value you have added to that queue. They will delete that one, right? So queue dot poll, we have this poll method, right? If we'll run this program, if you see, we got 20 and 89. They have deleted this first one because our queue works on which concept? FIFO, first in first out. So which value we have added first? This 10. Let me bring this queue before this deletion, right? See, earlier we have 10, 20 and 89, but here we have deleted one value. So if we'll delete any value from this queue, they will delete the first value. Whatever first value we have added to this object, they will delete that one. Okay, so in stack we have seen some method, right? Peek, search. So queue dot peek, we have this peek method as well in this queue. So peek will return the last one. We have this where is that? So if you want to check this size, we have this size method. Okay, we have this is empty method as well. So just q and dot, they will give you all the method that is present in this queue. All right, See, we have pick, we have poll, we have this remove method, we have this remove all. Alright, so this is the use of this queue. If you want to work with FIFO, we'll go for queue, and if you want to use LIFO, then you'll go for stack. So that is the difference between stack and queue. Only LIFO and FIFO. That's it. Okay. Now, yeah. So this is also done. Let me save this one. So after this queue, now we'll go for exception handling. Okay, let me save this one. 33. So what is this exception handling? Let me create one blank sheet. Okay, exception handling. What is this exception handling? So if you are trying to enter any value, I'm giving one example for that exception handling. So let me create one package first. com.amish.exception. Okay, exception example. Okay, so let me give one example for exception. So let me create scanner object, scanner sc equal to new scanner system.in. Right here I have declared one variable int num equal to sc dot next int, and then I am printing that num value. Alright, I am adding one message as well, enter your number. Right, now I have to enter some number here, but I have entered some different value here. Instead of this integer value, I have entered this string value. What we got here then? Exception in thread main java.util.input mismatch exception. Why we got this input mismatch exception? Because instead of integer value, I have entered here string value. If you see here, I have entered this string, but we have declared this integer variable here, na? So how can we store any string value to integer? We can't do that, right? So that's why Java throws this exception, input mismatch exception. Right, so this is the example for exception. So if you are getting any error, so that error maybe there is some issue with your code, and maybe there is issue with your invalid user input. So if you are getting these type of error, then Java will throw that exceptions that you are getting these type of exception. So input mismatch exception. So if you'll get this input mismatch exception, it means whatever value you have entered, it is their data type is not correct. That's why you got this input mismatch exception. Okay, let me show you one more exception example. So I have created int arr equal to new int, okay, 10, 20, 30, 40. I have added total four value to this array, right? Now I'm applying one for loop here. Int I equal to 0, I less than 5, okay, I plus plus. Want to we are like now we'll print this array value here, sorry, array of I, right? Total we have 4 value in this array object, right? Now we are trying to print this value I have for loop. Let me uncomment this one because we get exception that time. If you see here, we got here exception in thread main array index out of bound exception. Why we got this array index out of bound exception? If you see here, we have total 4 value in this array object, right? But we have executed our for loop total 5 times, but total we have only 4 value to this object, right? So when this for loop executed 5th time, that array didn't have that 5th value, right? And we are trying to print that 5th value via for loop. That time Java will throw that error, array index out of bound exception. Java will let you know, okay, in your array you have total 4 value, but you are trying to print 5th one. If you see exception in thread main java.lang array index out of bound exception, then 4. It means in your array object you have total 4 value, but you are trying to print 5th one as well, right? That's why Java throws this exception. So inside Java we have some predefined exception. So this array index out of bound, it came under java.lang package, right? If you see earlier we have used array list, linked list, all came under java.util package, but this array index out of bound exception came under java.lang package. So Java internally inside Java we have all the exceptions written over there. So if we'll get that type of exception in our program, Java will throw that exception that you are getting those error. Because of that, we are throwing that exception. So they have directly mentioned here, because of this size we are getting error. And then you also show the line number, like where in com.amish.ex package in exception example class you are getting that error in line number 16. If I'll drag this and let's show you, see, in line number 16 we are trying to print that value. So when they have executed this for loop 5th time, right, that time we got this array index out of bound exception, because we have only 4 value and we are trying to print this array value 5th time, I less than 5. It means 0th, 1, 2, 3, 4th and 4th, only up to 4th, like, because array index always start with 0. So if we are trying to execute this for loop 5 times, means 0, 1, 2, 3, 4, but we have only 0th value, 1 value, 2 value and 3 value. We didn't have that 4th one. So in this 4th place we got that error. Got it? How exception handling works in Java. If you have these type of error in Java, Java will throw these type of exception. So we can handle these type of exception in Java. So that's why I have mentioned here the topic exception and handling. Whatever exception we got, we'll handle those exception in our program. If you have these type of error, like if you have these type of conversion, data conversion, like you have declared this integer data type, we are trying to store this string value. So if I will return this error, like you are a user and I have written that program, you have entered some value and I have printed this exception in your machine. So you won't be able to understand these messages, right? What is this exception in thread main? So instead of this exception in thread main, if I'll print here, if I'll print here like array size is incorrect here, instead of this whole line, instead of this error, if we will return these line to that user, so then user will understand, okay, our array size is incorrect, that's why we are getting this error. So if we got any type of exception in Java, we can handle those exception in our code. So in exception handling, we will see how to handle these type of exception in Java. If you got any exception in your program, you can handle that exception, right? So let me add some note to this exception here. So first we'll see what is exception. Okay, then we'll go for exception handling. So an exception is an unexpected behavior. Unexpected behavior or behavior that occurs during program execution. Okay, it affects the flow of the program. Now what do you mean by this? It affects the flow of the program, right? Let me show you that one as well. So we have this program here. Let me execute this for loop total 4 times, right? So there is no error. Now there is no error. Now there is no array index out of bound type of exception in this line. But we have this input mismatch exception at line number 10, right? After line number 10, that all program is correct. If we'll run this program, and I have entered this string value here, we got this exception, that input mismatch exception, right? After line number 10, we got that exception, but after line number 10, every line of program, every single line of program is correct. So if we'll uncomment these 2 lines, right, and if we'll run this program, we got the output here, there is no error, right? So it affects the flow of the program. So if we got exception on line number 10, it means it will affect your whole program. They will throw that exception at line number 10 and they won't be able to execute after line number 10. So they will not execute any line after line number 10 because we got that exception at line number 10 itself. So they will throw that exception at line number 10 and your program will end here. Right? So this is the meaning of this line. It affects the flow of the program. Okay. So when like we have different types of scenario where you will get that exception. So exception scenario. Okay. What is that? So you can get that exception like invalid user input. So this input mismatch exception, you got this input mismatch exception here, right? At line number 10. So this is what? This is invalid user input. You have entered invalid input. That's why you got that exception. And you can get that exception like if you have any device failure. Okay. If any device failure is there, you will get exception that time. And is there any loss of network connection? That time you can get that exception as well. And if you have memory issue, right, you can get that exception. That time you can get exception. If you have any code error, they will throw that exception as well, right? So in these scenario, you will get exception in Java. Let me change their color to red. this to red. All right. So now we'll see Java exception hierarchy. Okay, Java exception hierarchy. Flag Java exception hierarchy. Okay. So we have these hierarchy, these exception hierarchy in Java. Throwable, and to type of this one. So one is error. Another we have this exception. Inside this exception we have two types, that is runtime exception, and the other one is IO exception. So this IO exception means input output exception. This runtime exception means if you'll run any Java program at runtime. So there is two scenario. Runtime. So when we have written this program, after writing this program, I'm clicking to this run as Java application. So internally, first they will compile this program. After that, they will execute that .class file in Java. So at the time of that compilation, after compilation, when they are running this program, right, at runtime, if we got exception, that came under this runtime exception. If we have run this program, right, so if you see, I have run this program, right. Wait. Let me uncomment this two line. Right. I have run this program. We didn't get any output. It means runtime. We didn't get this runtime exception. But after entering this input, when we are trying to enter some value, that time we got this exception, input mismatch exception. So this exception came under which class? IO exception, input output exception. At the time of input, when we are giving input to that value, to that variable, that time we got this exception here. So this came under this IO exception. So inside Java we have different types of exceptions. So we have categorized those exceptions in different side. So then we'll see each of them one by one, right? So let me this one, and we have this one, and then we have this one, IO exception and runtime exception. Okay, so these are the hierarchy of our exception in Java. Okay, so that's it for today. So tomorrow we'll discuss the rest topic, like what is this throwable, this error, this exception, this runtime exception, this IO exception. Inside runtime exceptions, we have different exceptions like unchecked exception, null pointer exception, arithmetic exception, illegal argument exception, array index out. So we got that array index out of bound exception, right? That came under this runtime exception. Then we have IO exceptions. Inside IO exceptions, we have different exceptions, right? So tomorrow we'll see the other exception example, runtime and the IO exception, and how to handle those exceptions. If we got these exceptions in program, we have to throw that error. So to that user will show some message, so they will understand that okay, we are getting that type of exception. Okay, so that's it for today. Thank you for joining. Yeah, have a good day.